Did you know that cells in our body talk to each other? I am Luis, and during my thesis, I'm developing chemical tools to visualize cell communication. Inside each of us, right now, our cells are sending and receiving messages to coordinate their function. This cell communication network uses a thin projection emerging from the cell, like an antenna, called the primary cilium. The primary cilium picks up the signals that guide the cell response to the environment. Importantly, when the structure or function of this antenna is affected, messages can no longer be conveyed, leading to developmental diseases collectively called ciliopathies. Like a telephone antenna is built of pillars, the primary cilium relies on a scaffold made of microtubules to transmit signals. What's really cool about microtubules is that cells need to paint them to form the antenna. Too much or too little paint on the microtubules can alter the stability and signaling of the primary cilium. But how do cells paint microtubules? The cell uses enzymes that act as painters. One of these enzymes is ATAT1. As a painter of microtubules, ATAT1 uses a paintbrush or cofactor to transfer chemical tags called acetyl groups onto microtubules. This process is called microtubule acetylation. Now, imagine being able to watch such a process in real time inside living cells. If only biology was that easy. Guess what? These acetylation tags are invisible, much like the enzyme painting white on a white canvas. To tackle this challenge, I am combining chemistry and biology to track ATAT1 as it paints microtubules with acetyl groups, just like watching a painter create a masterpiece. My goal is to imitate this natural process and make it visible. How? Remember the paintbrush cofactor used to transfer invisible acetyl tags onto microtubules? I'm making artificial cofactors that can transfer glowing acetyl tags instead. In addition, since natural ATAT1 cannot handle the artificial cofactors, I am engineering enzyme variants that can do it. To make it work in cells, I must find the best pair of artificial cofactor plus enzyme variant that will imitate the natural process. And this will give me the chance to pinpoint glowing spots exactly where acetylation happens on microtubules. My work will offer a more precise and reliable way to study microtubule acetylation. By developing these glowing painting tools, I aim to reveal the role of this process on the antenna's communication, both in health and in disease. Ultimately, learning more about communication in cells can help develop novel therapeutic strategies in the future.